Problem number 4 requires a lot of arithmetic again, so keep track of my arithmetic. Part A, we want to multiply this vector of size 3 by the scalar 2, which means we multiply each one of the entries components of the vector by 2, and we get the vector 2, 0, 4. B, it's again scalar multiplication, and the result will be 3, 0, 6. C, again scalar multiplication, and the result will be -1, 0, -2. And so now in D, I want to perform an outer product. I want to multiply the column vector by the row vector. So I know the result is going to be a square 3 by 3 matrix. And I notice if I think of these as matrices, I can do a partition matrix multiplication, or at least think of it in this fashion. And the result would be that if I want to take A times B, I know it's equivalent to A times the first column in B for the first column in the product, A times the second column in B for the second column, and so forth. And I know that 1, 0, 2 times, these are just scalars for each one of the columns, so I can change the order in which I think multiply, and this is equivalent to 2 times 1, 0, 2, which is what I answered in part A. So the result is 2, 0, 4 for the first column. Then for the second column, I'll take this vector and multiply by 3, and the result is 3, 0, 6, my answer for part B. And the last column will be -1, 0, -2. Now with that in mind, in part E, I want to again do an outer product, and I'm going to perform it in the same way. The first column is going to be 1 times this vector, which will be -3, 0, 1. The second column will be -2 times this vector, which is +6, 0, -2. And the last column will be 3, 0, -1. Now, I want to multiply in F this matrix A by this matrix B. Now again, these entries seem a little bit familiar. It seems to me that A is made up of the vectors that we perform multiplication with in D and E, and B is made up of the row vectors, again, that we perform multiplication with in D and E. So it seems to me like I can actually use the results in D and E to help me perform this, so I don't have to do as much arithmetic and I don't make as many mistakes. And I recall that when I have an update where I'm actually updating a multiplication where I have a column of B and an additional column in A and an additional row in B, that's what we called a rank 1 update. And the way we updated was we performed outer products. And so we could take the outer product of this first column with the first row in B and update by taking and adding the outer product of the second column of A with the second column of B. And so the resulting matrix is going to be a square matrix, which is a 3 by 3, and that makes sense because this is a 3 by 2, this is a 2 by 3, and the resulting matrix is going to be a 3 by 3. And I can find it by adding D and E together. And that would mean that the entries will be 2 plus negative 3. 3 plus 6 is 9. Negative 1 plus 3 is positive 2. Then zeros for the second row. And then the last row is going to be 4 plus 1, which is equal to 5. 6 plus a negative 2, which is positive 4. And negative 2 plus negative 1 is negative 3. And what I did was I performed a matrix multiplication by way of a rank 1 update in order to actually calculate F. Now, you could check it by performing the multiplication in some other fashion, and you should get the same results. But since we already had D and E calculated, it was most convenient just to add entry by entry to get the answer for F.